So of course you're asking yourself, how are these algorithms used in machine learning? So here's the good stuff. If you remember, initially there were three ways in which we taught the machines, and they were as follows: supervised learning, unsupervised learning, and reinforcement learning. We learned these from the last module. But this section here coming up, quite technical, quite mathematical, and this is really where the whole course pivots around the understanding of algorithms. The algorithm which a data analyst or machine learning engineer will choose to apply will depend very much on which type of learning is being applied. So out of those three, there are going to be algorithms which are specific to the individual types of learning. There are some algorithms which actually can cross over into each of those different categories. So for example, in supervised learning, we already know that supervised learning is probably the most common method. It's when you already have input values and you need a clear set of output values. And you hope that in teaching the machine hundreds of these examples, that eventually they will get it and be able to work out one of these on their own. The key equation here, it is going to get mathematical, is y is a function of x, of course. So supervised learning can itself be split into two further categories. And this is where it gets interesting. Stay with me. Don't be put off by the maths. So the categories of supervised learning are classification. And this is where the answer is always going to be just one of two options. So for example, on, off, cat, dog, green, red, man, woman, diseased heart, or disease-free. It can be applied to numbers, words, or even images, of course. Eventually, the machines will start to learn whether the picture it is now viewing is that of a dog or a cat. Algorithms in this case are known as two-class classifications. And generally, they will yield a visual representation like this diagram we've got here. You and I can understand this diagram. It's pretty much based on two entities. For classification type machine learning, there are certain algorithms that come into play within this area. And you'll see this coming up on CVs and job specs, but it's good to know. Random decision forest, support vector machine, average perceptron, great names. But random decision forest, for example, just to explain, is based on one of two results, yes or no. And it might look a bit like this. There is another type of supervised learning, and it's called regression. But it doesn't look like this. Here, you can see that the computer or the AI system just has to make a couple of decisions and lead down to conclusions at the end. With regression, however, the result could be a variable. It's not just on or off or yes and no. This is generally when the output has a real-world variable attached to it. So, for example, what is the price of coffee today? What is the average weight of chicken that comes out of our farm? What is the volume of water in a given river at any point in time? So these are great for, yes, this probably looks like a piece of spam email. So for example, that email spam filtering system has a range of values and conditions, and if the email coming in satisfies those, then it probably is spam, and it will put it to one side in the unsure or challenge box that you might be required to acknowledge. Sentiment analysis also comes in here. So for example, in social media sites, Facebook, Twitter, you can do a sentiment analysis of these sites and actually understand literally the sentiment of a geographical area like a country based on the sort of conversations that are going on at the moment. And when it comes to this type of learning, the algorithms at play are things like linear regression, this very common algorithm called naive Bayes, very commonly used. Less used is Poisson. Stepwise regression comes in here, as does logistic regression. So A linear regression graph will of course look like this. It's a simple one. What sort of mileage can you expect to get from a certain model of car on a simple diagram like this? You and I could understand this, but there are variables in there. A more complicated one might look a bit like this. And in this situation, we've gone slightly deeper. So this, of course, is looking at three critical variables: the weight of a vehicle, whether or not it's on city roads or on a motorway, and then how those two factors affect the efficiency of the performance of the vehicle. So it's easy to understand in a visual representation. But then, if you've got a graph like this, how do machine learning engineers use this sort of graph to teach AI systems or machine learning systems? Well, they do it through algorithms. And what does an algorithm do with this graphical version of the data? Let's have a look now.